Hello and welcome to my talk. This talk is about Kubernetes and looking at the question whether Kubernetes is the new OpenStack or even the better OpenStack. Few words about me. I'm the poorly shaved guy on the left side. Always happy when I can travel with a motorcycle through the mountains, forgetting about technology for a few hours to then come back recharged with new energy. I studied computer science and life turned me into a CEO. So to some degree, you have to forgive me when my technological depth has suffered over the years, but I try to, be as technical as possible. What we do is basically automate platforms for a living. We manage, we operate, we plan them, and we do automate lifecycle of data services as one of our main missions. As such, I have strong opinions about containerization, virtual machines versus containers. A few of these thoughts I will put into that talk. And here's a small disclaimer. This is opinionated content. Some of the similarities I will try to point out. There's a fire of different associations when I think about that topic. It was one of the talks I had, some trouble to getting those associations in order. So at the end of the talk, I'll try to, maybe have a discussion with you and get your impressions on that. So this talk is not meant to create consent, but to just reflect upon a journey that I've been through. And I think that maybe some of you guys had a similar journey. And if not, at least you can participate from the perspective and see whether you agree or you don't. Well, we are traveling back in time. It's 2010, and a young company, Anynines, called Avatec at that time, but the company was there. And we did a lot with ops code chef. So coming from physical service, we learned early that you want to take the agile development idea and apply it to automation. So we founded our company in 2008, and the first hosting that we had in the company, we had 3 employees, was a customer who had a lot of TV attention, and we had to bring up a 10-server cluster to host that application. It actually grew to 25 servers over time. And I mean, when you look into a cluster of 25 servers, you already start seeing repetitive work. And because the workload was basically from a single customer, there's enough homogeneity in the workload to see where a lot of wasteful tasks create those repetitive work and that you want to get away from by applying scripts to it. A few years later, automation such as Ops Code Chef and Puppet was, the new thing, and coming from the idea that, we should somehow apply programming strategies to the automation, and the software operation was a trend. But this had in mind that you take a sysop and you turn his task into something that runs as a program. And this actually created the problem that you do not really benefit from virtualization and advantages in something that became the programmable data center later on. So it was very good to have Chef because we had physical service here, we had a few virtual machines there, and the strategy was applicable to both. So I could at the same time take care of my 25 server cluster as well as those virtual machines that we carved out of our own infrastructure we built with Zen and had shared database clusters and a shared load balancer and all that kind of stuff. So pretty much what Engine Yard did back in the days. And then Amazon appeared, and it totally changed the way how people look at operating and automating their workloads. And one of the most fundamental changes, I would say, was the appearance of the ability to attach remotely operated block devices to servers, and therefore separate the ephemeral virtual machine from the persistent disk. Together with Amazon S3 as its object store, that was a game changer, because now you could programmatically start virtual machines where you don't have to take care of what happens to the data, because the data is there. And the most meaningful, let's say, benefit you get from that is that you don't have to spend a lot of money on the servers that will run your app, but you rather dedicate money to your storage servers, and you can combine the two. And you can only benefit from that if you deeply commit to that being a prerequisite for all the automation you put on top. So having a programmable data center that allows you to separate storage as attachable persistent disks to any ephemeral compute resource is a fundamental underlying concept that has changed the automation throughout. And for me, to be honest, I don't care whether it's a virtual machine or whether it's a container. There are several, let's say, different workloads where I prefer one or the other. But it was that time that really changed my mind. And at that point, I said to our engineers, to our DevOps, we have to move away from Chef. We have to invest into BOSH. And give me BOSH or give me Kubernetes, they represent the next generation of automation toolings we want to use. So this is infrastructure as a code. At least the idea is that you describe a distributed system in the desired state you want to have, and then you push a button and things will appear somewhere, somehow. You don't care about the details. You don't care about the underlying physical servers. And maybe you don't care about the underlying virtual machines or Kubernetes syncing into the hypervisors at some point. And this is still intact, I would say. There are changes, there are adaptations to it, but I think the general idea is alive. So in that time when we started picking up OpenStack, because we felt the pain that our Xen virtualized solution was getting over our heads, basically because managing the network manually doesn't work anymore at a certain starting at a certain scale. We were looking into OpenStack and find a solution that could be a drop-in replacement for Amazon, because I was very, very skeptical. The customers we had at the time, they were very sensitive to their data, and I looked into Safe Harbor, where American companies promise to self-certify being compliant to European privacy laws. I was like, yeah, but there's Patriot Act, and with Patriot Act, nobody gives a shit about the self-certification. You as a US company, if somebody says, give me that data, you'll give them their data, right? So I think that became clear, but we also overcame that phase because nobody cares anymore. We consider that to be not a problem. So large corporates do that. I've never met someone who's been dragged in court just because somebody put a workload on Amazon or Google on Azure. So we can safely assume this is not a problem anymore. However, there are still companies who are very sensitive and they want to have their own data centers, or they already have those data centers, and they want to have something that gives them the framework and the building blocks for on-premise clouds, which was one of the ideas behind OpenStack at a point of time. They want to have an API. They want to have the automation means to perform those or apply those DevOps strategies, establish continuous integration and delivery of software in general. So the idea of having your own private Amazon. But it turned out to be a valley of darkness. We've been through a journey with OpenStack. We started with Diabolo. I'm not sure how long you've been doing OpenStack, but we had a small team, maybe way too small. We've been always a software company, also doing software operations, and doing infrastructure is a different ball game, or whatever you call that in English. It was just not the right thing for us, and the software turned out to be hard to maintain. There were downtimes when upgrading. Stability was always an issue. And I've been traveling the world attending several OpenStack conferences, and the spirit of those conferences where OpenStack is the next thing. OpenStack is going to give you the answers to the programmable data center, to the infrastructure as code. It's going to be the next layer. You have so many different projects that imitate whatever is successful on Amazon. There are so many big brands behind that. How could that ever fail? It's not mature yet. Everybody has it. You have OpenStack? Yes, I have OpenStack. You do OpenStack? Yes, of course. And OpenStack and OpenStack. And everywhere was OpenStack. And where is OpenStack today? I would say that the community has seen a tremendous decline. There are certain OpenStack vendors who have survived, and I think the stability issues might have gone away. But it's safe to say that many have tried to establish that initial idea, and only a few succeeded. Maybe you're one of the lucky guys and therefore could descend to that statement. Or girls, please forgive me my ignorant use of the word guys. So I would maybe exaggerate and say that OpenStack is a failed promise because it has never delivered what people actually expected from OpenStack. I'd say with the ease of use people expected or hoped for. One could say that the hype cycle has ended. Or you could say that in George Moore's life cycle, we are now in a late maturity, and it's just natural that a product dissolves into another product category that emerges and takes attention from all the innovators and early adopters out there. I would say a litmus test to verify that statement that OpenStack has dissolved in Kubernetes is when you order an OpenStack and you basically get a Kubernetes. We see certain projects, for example, Piston has been bought with their Mirantis is there, and look at their website, I'll see, pretty sure on the website, first page, there's Kubernetes. So you'll get a Kubernetes there too. If you look into VMware and Project Pacific, you will see even a much stronger adoption of Kubernetes in infrastructure. But there was the container movement, and we from the Cloud Foundry community, we had this covered. So you have CF push, this is the way you operate your apps. But then Docker came, and I was like, who needs that? Why should I take Docker? Why should I take? I know that this question appears to be strange nowadays, but when I saw first Docker, I thought about open Solaris zones with ZFS, and I was like, oh, that was a cool thing. And why didn't that get that somewhere? Oh yeah, because open Solaris itself is a problem. But the idea was fundamentally nice, and I like that about Docker. And I also get that there is a problem with Cloud Foundry. And that is the legacy it has, or the heritage coming from Heroku and the 12-factor manifest. And one of the things that is problematic is the statelessness that every application has to have if you want to put it into a Cloud Foundry. And the container movement gave you this little nice experience. And in contrast to build packs, you can take it home. You can take it to your local computer. You can try it out. You come home as a developer and you download Docker, you create a container image, and the syntax is so nice, the user experience is nice, and what you get is something that rewards you. So that is a bottom-up community where developers drive and adapt and make their bosses to adapt to a technology, whereas Cloud Foundry has been top-down, where organizations and C-level managers have been convinced, because this gives you governance in a digital transformation. So this is where those two waves had to collide at some point. And I would say that the container orchestrator is where those two different movements have met. So in general, there's another aspect. It is the question whether you do container orchestration or whether you do virtual machine orchestration. the problem is similar. You have those vertical servers that they have many CPUs and they have much of memory. And the problem any orchestrator here has is it has to carve up those virtual machines into smaller chunks and offer them for auctions to place workloads across the cluster. And whether this is VMs or whether this is containers, this is basically the underlying thing you want to achieve. If you remember the idea of Mesos in or those yarn-like cluster managers, then you have a different approach where you join all your compute resources and throw larger workloads at it and expect the cluster to take care of it. So those are two ends of a spectrum. And when you take container orchestration and VM orchestration, there's a lot of overlap conceptually. So you have a container, it will contain your application with respect to memory and CPU, and you have a virtual machine which does basically the same but with more isolation. However, if you take the OpenStack and the OpenStack API and you compare it to Kubernetes, you see another influence that has just changed the way how workloads are described today, which is that OpenStack has a very RESTful API. So you basically tell the compute service, Nova, or whatever it's called, well, give me a virtual machine. But who cares about a virtual machine? Nobody cares. You want to operate a certain application. And this is where technologies such as Cloud Foundry and BOSH actually have been a game changer. You describe a system, a distributed system, declaratively. And then you push a button and you actually pass on the responsibility to some scheduler that runs a loop and continuously compares the actual versus the desired state. So you have this declarative API where you describe a distributed system and how it works. So you get self-healing virtual machines with BOSH, you get self-healing containers with Cloud Foundry, and you get self-healing pods with Kubernetes. Usually there's something like load balancing or routing integrated, so you don't have to take care about that. You don't have to create a virtual machine, take your image, attach it there, take your persistent disk, attach it there, take a load balancer and put it there. That's all wasteful tasks. I want to have a language that lets me describe my workload of a distributed system, and I just wanted to pass it on. So it's more lifecycle management than it has been before. Then we actually started to think about what is actually the best container scheduler out there, and because there's overlap in Cloud Foundry and Kubernetes, there's been a term coined called orchestration wars. I'm careful with the word war because I don't like it, maybe because I'm German, but you get the point.
Don't blame you, I'm German.
I'm saying there have been competing technologies for solving this problem, and I think it's clear the winner is Kubernetes. And I don't think that this is a bad thing, because Diego, for example, brilliant implementation, I would say. It's solid, works at scale, but it's purpose-bound. It is restricted. It does not give you the freedom you want to have. In the other talk I held earlier today, I said that there's a certain aspect to the legacy apps in a large corporate. Applications that are not actively maintained anymore, that they are close to being 12-factor compliant, but they are not because they write something into the file system and they expect this, whatever they write into there, to be there, even if an application had to be restaged or restarted. So with allowing containers to have state, well, the path has been opened to give all those applications a home. However, we also invited people to put stateful workloads into a Kubernetes cluster that don't belong there, that actually belong in virtual machines. So we actually conduct tests where we take Kubernetes, we put a workload in there, a database, and we co-locate two different containers on a node, and we'll, create some traffic, and you will see that the performance of the individual machine becomes unpredictable. I will repeat that throughout the talk because that's a very important topic on understanding how OpenStack and Kubernetes relate. Because OpenStack, and I'm talking about the state as it is today, to my best knowledge, allows you to schedule a para-virtualized or full virtualized or if you want to, a containerized workload that will give you the isolation, if you want to, suitable to ensure that the database you are deploying has a predictable performance. If you don't overcommit, you can basically ensure that the node dedicated to Postgres will do its job as expected. Whereas you put that into a container, you have no I/O isolation for disk I/O, no I/O isolation for network I/O, and this will make you headache. And once you run into a problem like that, you'll have to, find the rabbit in your hat to solve it, because it's non-trivial. Well, there's onion skinning and the cloud stack collapsing under its own weight. So the hypothesis here is that you will have your hardware, you have your OpenStack, and then you have your Kubernetes on top. And now there are people in this community stating that this is not a sustainable model, because the overlap in Kubernetes and OpenStack is so big that we do not tolerate both layers, because they both add a complexity and they both can fail. So the assumption is that in Kubernetes as infrastructure, Kubernetes will also cannibalize the market of, let's say, who's going to be the first go-to API to orchestrate workloads tomorrow. And it seems like Kubernetes is at least being tested to become that too. That gives three major use cases for Kubernetes. First, for applications. You describe your application workloads, send it to Kubernetes cluster. Second, Kubernetes as infrastructure, where you basically describe your workload, leave it to a Kubernetes cluster, even if it's a database or something similar. And the third, which is maybe a special case of this one, would be Kubernetes for edge devices, where you do things like automating factories and your computers are distributed across, spatially across a factory or something like that. So if you look at Kubernetes as infrastructure, there are several approaches that you can see in the market today. One is, for example, where Kubernetes will be presented to you as a managed service. You get access to the API, and you basically don't care what's underneath as long as it's a Kubernetes. You can see that on public infrastructures, and it's a bit, the gotcha there is that you don't have the flexibility to turn, let's say, a knob at the master on or off. So it's either a predefined something that you can switch on or switch off, or you don't have the possibility to do that. There are other tools, such as COPS, for example, where they allow you multi-infrastructure support. And I tried to separate the infrastructure agnosticism from the infrastructure support, because in COPS you have to invest quite a lot in order to explore a new infrastructure if you are a maintainer of COPS. Whereas, for example, if you use CFCR, you can basically bring Kubernetes to any infrastructure, because BOSH has already explored the infrastructure and comes up with a CPI. So from the person or the group maintaining this automation, that's a huge difference. There's another project that at least raised my awareness. It's VMware Project Pacific, where, and I'm not the expert on VMware, but if I understand it correctly, you take the Kubernetes API, I'm exaggerating the statement, but Kubernetes to somehow melts into the not the hypervisor exactly, but the API the infrastructure provides to you. So what does it mean? Now, I stated earlier that it is a problem that stateful workloads are not properly isolated. Now, if you have a first-class citizen where VMware, for example, can create a pod that is isolated with an on-demand provisioned VM, well, then that gives you the isolation. And that solves actually a very important problem that is currently an obstacle for placing databases in a Kubernetes. So Kubernetes on bare metal, people do that. Well, I don't comment so much on that. If you're a data center and you're good in bootstrapping systems and there is means to strongly isolate containers from another, maybe that could be a thing. But unless you have that strong container isolation, I don't think that this is a good idea, unless you tolerate other automation systems right next to it that will solve the problem. In general, the question is whether Kubernetes sinks and melts into deeper layers of the cloud stack, because you don't want to have this onion skinning to be arbitrarily high. So the question is not, does Kubernetes represent the new OpenStack, but does it become the new infrastructure API standard? In general, the question today is who will operate your Kubernetes, and Kubernetes is already covered by many different automation products. So it seems to be a primary assumption of the community that this problem is considered solved or will be solved soon. So the question is, in general, do you have a suitable replacement for your infrastructure looking at Kubernetes? And is this the end of BOSH? Which would be a closely related question. I'd say that the question of looking at stateful workloads in Kubernetes is one of the litmus tests to find it out. It's basically a sentence from the Kubernetes documentation. It says, moving your storage application into Kubernetes isn't always the correct choice. And you have to look at the question, how important is predictable importance for you? The reason I already stated is that bad neighborhood issue occur when the isolation problem hits you. So imagine you have two virtual machines that are sitting right next to each other, and one of which is very noisy. So you have a Postgres database, and there are frequent access to it, and there's a lot of I/O disks. So with a VM, there are opportunities to set quotas, and you shouldn't see so much of a problem. So whatever is the guy doing on the right side, he will continue to do so. So you got strong isolation, you have, well, let's say, rarely bad neighborhood issues, and to some degree predictable, or to a sufficient degree, predictable performance. Now, if you take two databases and they're collocated on the same node, and you repeat the same thing, the same workload, and you will see that they will influence another, and that this is a problem that needs to be solved. Until, because if you're there and you don't have a proper solution at hand, well, that creates a lot of emotions, I can say. So one of the statements is one does not simply predict container I/O performance. And I already hear the people saying, well, but you can work around that. Yes, you can. You can, for example, use labels, you can use anti-affinity and host affinity to do that. But, well, we've created that framework based on BOSH, and customers, they provision 1,000 Postgres or mixed, we have 8 data services, and they have 3,000 virtual machines with BOSH. So you create a virtual machine or a cluster, 3 virtual machines, you update them, you scale them out, you delete them. Everything is all right. On-demand provisioning is helping you to create microservices there, provide them with data services, and there you go. We don't have to care about having a container and whether the container has a certain node, because the underlying infrastructure has solved that. So if there's a physical node or not, it's not our problem. The infrastructure team takes care of that. So if you take now and put that into a container, you have to find somebody who takes care of your Kubernetes and ensures that whenever you create a new database cluster, there is a Kubernetes node that has not co-located a noisy neighbor. So whatever you do, unless you create a container that's well isolated, this puts the burden of scheduling to some degree on your shoulders. So you have to find ways to do that. Well, you can do that, but the question is, why do I have to solve a problem that's already been solved? So it influences the way Kubernetes schedules a container, avoiding bad neighborhood. And one of the possible solutions would be to have on-demand provisioning of Kubernetes nodes that are tagged in a way that when you want to create a Postgres node container, that it will have an affinity to exactly that on-provisioned virtual machine you got. So basically, give me a container with Postgres. Do I have a Kubernetes node suitable for Postgres? No, create me one. Well, there you go. But as I said, it introduces complexity. So avoiding bad neighborhoods in Kubernetes is a problem. And I actually don't want to care about the placement of my word. This is either you give me a well-isolated container for that purpose, or I will use a VM. So I want Kubernetes, but I need this virtual machine for now. So this is the idea I just presented. And I actually want to forget. I don't want to forget to delete those nodes I on-demand provisioned when my container has been destroyed. So why do I have to do that? It's because there's no container isolation yet. This is why this VMware Project Pacific seems to be so interesting. And summary. Kubernetes API seems to become popular and replacing infrastructure APIs. So instead of talking to the individual APIs of the underlying infrastructures, especially if you deploy your workloads across different infrastructures such as AWS or Azure or whatever, well, you're welcoming a common API standard. And if Kubernetes becomes something that's just available everywhere, similar enough so that you can stop caring about where it comes from, well isolated enough, well then you can have the better OpenStack. So my prediction is that there will be several Kubernetes flavors and that they will be more targeting those issues because people already do that and those questions need to be solved. Until then, and we are offering the data services for Kubernetes as well, but we still tell customers, if you really care about your databases, go with the VMs. Opinions are very welcome. So, do you have any questions or remarks on those many opinionated statements I have made? Thank you.